Everybody, these are the second half of your stoichiometry notes. Remember, we just finished this mass to mass stoichiometry problem, and I told you I was going to come back and talk about the mole map, or what you can use if you get stuck on a stoichiometry problem. Now this, you can write this on your conversion card so you can use it during your test if you get stuck. So the problem we just did, it started with grams of the given. I'm going to use A for given. So grams of the given, and we multiply by 1 mole over the molar mass in grams. Remember, molar mass, you find that by looking at your periodic table and adding the masses together. That gets you to moles of A, so that's what's on top. Then you can do your mole ratio step, where you put moles of the given on the bottom and moles of what they're asking for on top. The mole ratio step comes from the balanced chemical equation. That's the only time where moles might be a number that's not 1. You can see in all my other little conversion boxes here, the number by the moles is 1. Then if they're asking for grams, you would use the molar mass again, but this time the molar mass of what they're asking for on top and 1 mole on the bottom. Your other option, we haven't done this one, but they might give you a number of particles, like how many atoms or molecules there are. And then you use the 6.02 times 10 to the 23rd to change it to moles. Then you still do the mole ratio step. The mole ratio step is always in the middle here. It's always moles of what they gave you on the bottom and moles of what you're trying to find on top. And then you might go to grams, so you might use the molar mass, or they might ask you for particles again. So you can go lots of different ways through this. You could start with grams and then do the molar ratio step and then go to particles, or you could start with particles and go up to grams. You could also stop here. If they're asking for moles, you might not do one of these last 2 steps. Okay, so you can pause this, get this on your conversion card, and you can use it. Some of you might have to use it every time. Most of you should be able to figure it out so that you don't have to use that every time. All right, let's try another mass to mass problem. Here, they have given us an equation, but they haven't balanced it yet. So let's do a little practice with balancing first. We've got 2 coppers on this side of the equation. So I would start out by putting a 2 here. So now I've got 2 coppers and 2 chlorines. And if I look over here, I only have 1 chlorine. So I'm going to put a 2 there. That gives me 2 hydrogens. I have 2 hydrogens over here. I only have 1 sulfur over here, but I only have 1 sulfur over there too. So it looks good. Just need some 2s to balance it. The other thing you might do, what I like to do, is take what they're giving me and put it up on top of my equation or my reaction. They're asking to calculate how many grams of copper 2 sulfide you can produce if you start with 9.9 grams of copper chloride. In both these problems we're doing, they're giving us a reactant and we're finding the product, but it doesn't have to be like that. They could have given us a product and we would find the reactant, or they could give us amount of this reactant and we could find the other reactant. So you can go any different direction on here. You can go from reactant to another reactant. You can go from reactant to product. You can go from product to reactant. You can go from product to product. All right, but this one, we have 9.9 grams, 3 sig figs of this one. And we're trying to get over 2 grams of that one. And that kind of tells you what you need to be focused on and what you can ignore. We're going to ignore this acid, the H2S, so we're going to ignore this acid. They've told us that we're reacting with an excess of H2S, so that means that we won't run out of this. It's not going to run out before the copper chloride runs out. All right, so now I can start my problem. I'm going to put the 9.90 grams CuCl on top. And my 1 on the bottom. you can use your little chart here. So I'm starting with grams, just like the last one. So then if you need a hint of what to do next, you're going to do this mole or mass step where you put the moles of 1 mole on top and the mass of 1 mole on the bottom. But you can also just think through this like we've been thinking through it. You're going to take the unit and the label and copy and paste it down here. And whenever you're trying to find mass, that's where you have to look at the periodic table and add it up. So I'd find one copper and 1 chlorine and add them together. So copper is 64 plus chlorine is 35. All right, so that gives me 99. Again, I'm putting the whole label there. You won't get points for your work if you don't have all the labels on it. And now, once you're to moles, your next step is to do the mole ratio step. So I have moles of this on the bottom. And moles of whatever I'm trying to get to up on top there, that my X here is above this. This is what I'm trying to get to. Oops. And I'm pulling the numbers from the equation 2. I've got 2. 2 is with the copper chloride here. I'm going to put my 2 down there. And I've got a 1 here. So that means I'm going to put a 1 here. For every 2 moles that I start with of the copper chloride, I only make 1 mole of this. And that should make sense mathematically. This molecule only has 1 copper in it, and you're making a molecule with 2 coppers in it. So it should make sense that you have to have 2 of these to make 1 of those. If they were asking for moles, I would be done, but they're not. They want grams. So I got to keep going. But now I'm in the unit that they're asking for. So I'm going to copy that. Put that down here so it cancels. So I need to do my molar mass step. And now I have to calculate how many grams that is. I would look at my periodic table again and add up 2 coppers. 64, I'm rounding it up, 64 plus 32. And I already did that, that's 160. And then that's it. They're asking us for grams of Cu2S, and that's what we found. So now we can go ahead and multiply that all together. If you're plugging in all those fractions, you could just multiply it all together. But I would just do 9.90 divided by 99 divided by 2, because the 2's on the bottom, times 160. And then you're still doing sig figs. You're still doing scientific notation. So when I plugged it in, I got 8, but if you look at the number that they give you to start with, it's got 3 sig figs. So I'm going to have to stick some zeros on here, 0.00, to make it have 3 sig figs, times 10 to the 0, because it is exactly 8. But we will have to do scientific notation. And then I have to put a label on there if I want the points for it. 2S. Okay, so remember, to get all the points, you have to show all your work. You have to show all your labels. You have to do sig figs at the end. We're pulling everything we've learned this year together to do these problems, especially on this last one, because they have not given us the equation. They've told us that we've got calcium hydroxide, and it's going to react with phosphoric acid. They've given us that formula because I didn't teach you how to write acids. and it's a double replacement reaction. And they're going to calculate, they want us to calculate the mass of calcium hydroxide needed to react with 10 grams of the phosphoric acid. Now, your first step would have been to write those numbers on your equation, but you don't have an equation, so we have to do that first. Remember that we're going back to figuring out what the charges are and crisscrossing our charges. So I'm going to get in here so I can write the charges. Ca, if you look at your periodic table or your ion sheet, calcium, it's been a while since we've done this, is a +2. We've got +1s here, +2s here. Calcium is a +2 charge. Hydroxide, I don't have my polyatomic ion sheet pulled up, but hydroxide is OH minus. And then you're going to crisscross those. So you're going to have CaOH. You have to put your polyatomic ion in parentheses. That's really key here because you're going to be getting wrong masses and you're not going to be able to balance the equation if you don't do that. Okay, so I'm going to make it a little easier. I'll just copy and paste that down here. All right, plus, oops. They also haven't told us what the products are going to be, so we have to think about this one. This is a double replacement reaction, which means that our two metals switch places. The hydrogen and the calcium are going to swap spots. So I'm going to put the calcium with the phosphate, and you have to remember your charges. Ca is +2. Phosphate, you have to look up on your polyatomic ion chart if you don't remember what it is. It's PO4, and then it's a -3 charge, and then you got to crisscross. So it'll be Ca, and then do your 3, and then PO4 in parentheses. And then cross your 2. This is an acid-base reaction, which is a little tricky to see the other product. We have H and we have OH. So HOH, if you write it like that, HOH, that's H2O, which is water. H2O. All right, now, closer, we still have to balance it. The first thing I would do, it's up to you in what order you want to do it, but I automatically see this 3 here by the calcium. So I'm going to put a 3 here in front of this calcium. And then I see this 2 for the PO4. So I'm going to put a 2 here for the PO4. And then you kind of just hope all of your hydrogens and oxygens work out. But let's double check them. So if I have to distribute this 3 to the oxygens and then multiply this by 2, I've got 6 oxygens here, plus those 8. 2 times 4 gives me 14. And then I've got 8 here. Okay, so that doesn't work yet. We're going to have a number here in front of our hydrogens. Hydrogens, we've got 6 here. And then if I distribute this 3, we also have 6 there, distribute the 2 and the 3. So that means I've got 12. To make this 12, I'd have to have a 6. And that also works for oxygens because we had 14 on this side. And now we've got 8 plus 6 gives us 14. All right, that's important. Those are the numbers you're going to need to do your mole ratio step.